Yes, sir, you can start now.
Thank you, ma'am. Good evening, all of you. Today we are going to learn about this properties of triangle and question based on that. Okay, that is the part of your geometry. So before that, we will just understand what are the topics are there, like chapter wise, and what is the mark means like you will get based on those chapters. So first one is your number system. In that number system, you have real numbers that will have 6 marks. Algebra, these three things: polynomials, linear equation, quadratic, and arithmetic progression. So that will carry 20 marks. Coordinate geometry, so again 6 marks. Geometry will have triangle and circles. That triangle we are going to cover today. That will carry 15 marks. Trigonometry is your intro and applications of trigonometry, 12 marks. Mensuration, 2 chapters are there, which will carry 10 marks. Statistics, again, including probability also, it will carry 11 marks. So total 80 marks will be there. And when we talk about this triangle, so there is 5 parts. So that is first one is your introductions. Next one is your similar figures, similarities of triangles, that criteria of similarities, okay? And then Pythagoras theorem. So in this, what is the weightage of all the topics? So highly scoring topics is 6.4, means criteria and similarities of triangles. So that we are going to focus in today's class. Fine. So maximum your type of questions that will be so from 6.3. So that similarities of triangle, MCQs, short answers 1 and 2. This both are from, or long answer that will be from this criteria only. Okay, similarities. So that we will cover today. So congruency already we have learned. So in junior classes, so little bit we will understand. So like in congruency, if two triangles, we can call it as congruent when these two triangles, all angles are, corresponding angles are same and corresponding sides are equal. Means suppose this and this is corresponding side and this one is a corresponding side. So obviously this third side will be the corresponding, which is equal. Okay. So then your corresponding angle also will be equal. So this angle will be equal to this. This angle will be equal to this. And this one will be equal to this angle. Okay. So this is all about this congruency. Fine. So there are 4 criteria that already we have learned. Okay. So similarities also is something similar to that. Okay. So in similar triangles, so here you can see these two triangles in congruency, your shape of this structures means like these triangles, two triangles, their shape is equal and their size is also equal. So both is equal. So then it is congruent. But if here your shape is equal, but size is not equal, in that case, so we can say that it is a similar triangle. Okay, like we can take the example. So like these two triangles, okay, so their shape is the same, but size is different. Okay, so we can call it as a similar triangle when there's a condition for that. So similar triangle, your corresponding angle will be equal. Okay, so like this is the corresponding of this. So if you want to give the name, this is a triangle ABC. Okay, and this is triangle PQR. So here angle A will be equal to angle P, angle B is equal to angle Q. So obviously when in a triangle, two angles is equal, obviously third angle will also be equal. Okay. So this C will be equal to R. Okay. So these three angles is equal. Okay. And the ratio of their side will also, ratio I'm saying in congruency side will be equal. But in similarities, your ratio of side will be equal. Suppose if I will say that side AB is your 6 centimeter, okay, and side PQ is 3 centimeter, means ratio is 2:1. Okay, so in that case, if BC is a 4, okay, 4, no, sorry, so better we will take 8. So this will be 4. Ratio is again 2:1. And here third side is, if it is a 10, so here PR will be 5. So what we have seen, ratio is constant 2:1. Here also it is a 2:1, and here also it is a 2:1. So similar triangle, your angle will be equal and corresponding sides will have same ratio. Okay, so it is called similar triangle. So here all congruent figures are similar, but not vice versa. What it says, so if two figures are congruent, okay, like this and this, it is a congruent. Okay, so definitely it will be similar because their angle is equal and their side ratio is also equal, 1:1. So all congruent figures are similar, but all similar figures are not congruent. Like these two figures are similar, so it will not be congruent. Why? Because their side is not equal. In congruency it says size is equal, but in similarity side ratio is same. So all congruent figures are similar, but all similar figures are not congruent. Okay. So next, two n sides of polygon are similar if their corresponding angles are equal. Just now we have discussed when it is a similar, when their corresponding angles are equal. Okay, and their corresponding sides are in proportional, means they are in same ratio. Like here we have seen 2:1 ratio, all sides are in 2:1 ratio, so their sides should be proportional, then only it will be similar figures. Okay, so now we will talk about the similar triangles. Like two triangles are similar when their corresponding angles are equal and their corresponding sides are proportional in same ratio. Okay, so like here you can see this another example, like this triangle. Just let me delete this so you can clearly see the figure. Yes. So here you can see, so two triangles are there. One is a triangle ABC, this is small one. Another triangle is your DEF. Okay. So here these two triangles are similar if their corresponding angles, like here you can see, so corresponding angle of A is D. These two angles should be equal. Corresponding angle B's corresponding angle is E. So these two angles should be equal. So obviously then third angle will also be equal. Okay. And their ratio of the side. Okay. So here your angle A is equal D. Angle A is equal to angle D. Angle B is equal to angle E. B is equal to E and angle C is equal to F. That is the one condition. And next, their ratio, side of ratio should be equal, like your AB is to DE. These two sides are corresponding, their ratio. Then BC is to EF. Your this BC is ratio to EF, and ratio of AC and DF is same. Okay. So that is the property of similar triangles. So if anyone has any doubts, so please let me know. It's okay. So now we will move to this basic proportionality theorem, or it is called Thales theorem. That is a very much important. So many times directly they ask you this in examination to prove this theorem. Okay. So and this proportionality theorem, it is required to solving so these questions. So you has to understand it properly. So what this basic proportionality theorem says, here it says that if a line is drawn parallel to one side of a triangle, okay, to so okay, so sorry, I think some problem has happened. Yeah. So here say that basic proportionality theorem, here it says that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point, okay, the other two sides are divided into same ratio. What does it mean? Like if triangle is there and that triangle is like ABC, and we draw a line which is parallel to the third side. So here we are assuming this BC is the third side. So we have drawn a line parallel to this BC. Okay. And we are assuming this point is P and this point is Q. So what it says, So intersecting the two other side AB and AC. So it is distinct to distinct point. The other two sides are divided into same ratio. Means your AP and PB, whatever ratio it is. So AQ and QC also will have same ratio. It means your AP by BP, it will be equal to AQ by CQ. Okay. If it is like 1:2 ratio, example I am taking, if it is a 1:2, so here also it will be 1:2. 1:2 ratio. Fine. So that is your basic proportionality theorem or Thil's theorem. Fine. So we have that, so we can prove it. So how we can prove? So here we have taken triangle ABC where D is, so here it is a taken DE. Okay, I think diagram is there already. So whatever I have drawn, so just I will remove it. Okay. So here this triangle is ABC. Fine. And what it says, D is parallel to BC. So here it is a D that we have drawn parallel to, this is a parallel to your another side BC. Okay. And AB and AC are intersected by DE at point D. So here AB is intersected at point D. This point is D. Okay. And AC is intersected at point E. Okay. So now what we have to prove? AD by DB, this AD by DB, that is equal to AE by AC. Okay, so this one we have to prove. Fine. So what we will do, we have joined BCD and drawn EG perpendicular to. Here what we have done, we have joined this BE, this one. Fine. And we have joined DC. So these 2 points we have drawn joined, and next we have drawn a perpendicular altitude from from D to side AE. So this is the perpendicular we have drawn here. Similarly, from E we have drawn another perpendicular on AD. So this is the perpendicular we have drawn. Fine. So that is the construction part we have done. So now, so we will take this triangle ADE. So let me change the color so it will be visible to you. So triangle ADE. So here triangle ADE. This is the upper smaller triangle. Fine. So in this upper smaller triangle ADE. Okay. So how we can take the area of triangle ADE? So that is half into base into height. So we know this is the height given. So your height is GE. So your base will be AD. 8 is the base and this G is the height. So area will be half into AD into EG, height. This is the base, AD is the base, EG is your height. Fine. Similarly, now we will take triangle DBE, which is a downside. Triangle. Okay. So triangle DBE, again. Yeah. So this is the triangle, downside. This is the triangle. Fine. So when you will see this triangle, so your base is now DB, this is the your base DB, and height will be same DF. So whenever you have obtuse angle triangle, like, okay, this is not very much visible. So let me change the color. Yeah. So when you have obtuse angle triangle, so your height will be always outside of the triangle. Fine. So same concept we will use here. So here your triangle is DBE, your height is again your EG. Fine. So now area of triangle the DBE will be base is your DB, height is your EG. So that we have taken. So area of triangle DB is equal to half into base into height. Same thing we will repeat again. Triangle now we will take, earlier we have taken AD as a base. Now we will take AE as a base and height will be DF. Height will be DF. So that we have taken area. Okay. So in next case, we have taken half into base is your A, height is your DF, and another triangle we have this side. Another triangle we have this side. That area also we have calculated similar, like how we have calculated earlier. Same way we have calculated this area also. Okay. In first case, we have taken ratio of both area. In second case also, now we will take the ratio of both area. So what finally we got? AD by DB and here AE by EC. So these two equations we got. Okay. So here your triangle DBE and ECD, your DBE, this downside triangle, what two triangles we have taken? No, this downside two triangles. Okay. So they have same base here. So let me delete whatever I have marked. So here if you'll see, so these two triangles, your DBE and DEC, these two triangles having same base D. This is the base for both triangle. And they are between two parallel lines. Two parallel lines means their height will be same. Okay, their height will be equal. So when two triangles base is equal and height is equal, so their area will be equal. Okay, so that's why these two triangles area is equal. So now this relation we will use this equation 1, equation 2 and equation 3. So these three relations we will use, and then we can conclude that your AD by DB equal to AE by AC. Okay, so that AD by DB, that is equal to A by AC. So it is proved. Fine. So this is a very important theorem. So you has to understand it properly. Okay. So next is important observation. Basic proportionality theorem. What we have seen, like in triangle ABC, if in triangle ABC, D is parallel to BC. Okay, so what will happen? So your AD by DB is equal to AE by AC. That we have already seen. Another thing, what we say, AD by AB means like this, AD by whole side. That also we can say AD by whole this side AB is equal to AE by whole side AC. That also is true. And next, your similarly BD by whole side is equal to CE by whole side. So any relation out of these three, any relation we can use when your two triangles are similar. Okay. So next is converse of basic proportionality theorem. So proportionality theorem, what it says, when these two lines are parallel, so this side will divide into same ratios. Fine. So converse of basic proportionality theorem, what it says, if a line divides two sides of a triangle in same ratio, means here they said that it is in same ratio. First they had given the ratio. So here like this line. Yeah. So this line divides this in same ratio, like if it is dividing in same ratio, x is to y, here also x is to y. Okay. So then in triangle ABC, D is a such line which is parallel, means like then in that case, if it is dividing in same ratio, so DE will be parallel to BC. So basic proportionality theorem, what it says, when it is a parallel, it will divide into same ratio. Converse will say, if it is the same ratio, these two lines will be parallel. That's it. So just opposite to that. So these are the two things we are going to use. Next is your angle bisector theorem. So angle bisector theorem, what it says, so if there is a triangle, sorry, so, yeah. So if there is a triangle, like triangle ABC, where this, suppose I am dividing, so here it says that internal angle bisector of any angle of a triangle divide its opposite side internally in the ratio of its other two side. What does it mean? So here in triangle, like if I assume this AD is angle bisector, this is a AD and this is an angle bisector. Angle bisector means it will divide this angle A into two equal parts. This and this is equal. So it means this BD and DC will divide into AB and AC ratio. In this same ratio means your BD by CD is equal to AB by AC. So that is angle bisector theorem. So clear? Anyone has any doubt in this angle bisector theorem? Okay. So next is your converse of angle bisector theorem. Just opposite to that. Here it says that in a triangle, if a line drawn from vertices of a triangle divides opposite sides. So what does it mean? It says that in a triangle like same ABC, if you draw a line like this, and it will divide opposite side in same ratio as its another two side. Like if side is x, y, so it divide this opposite side into same ratio, then this line will be angle bisector. Okay, or this point D will be on the line of angle bisector, just opposite to that. Here bisector will divide side into same ratio. Here in converse, if side is in same ratio, this line will be bisector, angle bisector. So hope you people understood. If you have any doubts, so please let me know. Okay. So now we will, like congruency, we have criteria for similarities also. So congruency, we have 4 criteria. Similarities, we have only 3 criteria. Okay. So first criteria is your SSS. Okay. So here SSS is your side, side, side. So we know in similarities, whenever it's talk about the side, their ratio will be equal. In congruency, side is equal, but in similarities, their ratio is equal. What it says, if two triangles are such that their corresponding sides are proportional, their ratio is same, okay, then they are equiangular, and hence, and the proportional first side is proportional and their angles are equiangular. Okay, so then two triangles are similar. Okay, so here, so obviously when these three sides are your like ratio is the same, so they will be equiangular. We need not to check, the angles. Just we have to see this three sides ratio should be similar. So like S, if like in starting we have taken example, this is small, this is a small triangle. If this is like yeah, so this is a 6, this is a 3, this is 8, this is a 4, and this is 10, this is a 5. So ratio of three sides are equal. Fine. So 6, 3, 2 is to 1, 2 is to 1, 2 is to 1. So this two triangle is similar by SSS. Okay, side, 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 because three sides ratio is the same. Okay, so these two triangles is similar. That is the first criteria. Second criteria says SAS. Okay, SAS means two sides having same ratio and including angle. Angle should be between them. That we has to always keep in our mind. When this criteria, when in congruency also, this A angle should be between these two sides. It should not be outside. So similarly here, this angle should be between two sides. So just now we will understand with example. Like here, two triangles are there. Okay. So here side is like this is a 10 and this is a 5. This is 8. This is a 4. And the including angle means angle between these two sides. This angle is equal to this angle. Then this two triangle will be similar by SAS, side angle side. Fine. If I say, okay, this angle is not equal, maybe some other angle is equal. Like if I'll say this angle, this angle is equal. So in that case, this two triangle is not similar. Okay, it is necessary that this angle should be including, it should be between these two corresponding side, not this one. Only then this two triangle is similar. So it says that if one angle of a triangle is equal to one angle of another triangle, okay, two angles are equal, and the side containing these angles means angles should be between them are proportional, then the triangle are similar. This is the second criteria. Third criteria is angle. If two angle is equal, okay, so obviously third angle also will be equal. So some places you may see A three times, but it's not required. Only two angle is equal. So obviously third angle will be equal. So that criteria is AA. Okay. So if two angle of a triangle are equal, okay, so then both triangle are similar. Like if we say this triangle, this angle is equal to this angle, and this angle is equal to this angle. Okay, so these two triangle will be similar by angle criteria. Fine. So hope you people understood these three criteria. If you have any doubt, so please let me know. Anyone has any doubt? Okay. So that is about the similarities criteria. Fine. Now, here in a triangle ABC, this is the questions finds. Okay, so here so I will show you the solution, and like if you suppose if you solve this question, so step marking, how you will get the step marking, that I am going to explain you. So here it says that triangle ABC, this is a triangle ABC where D, E and F are midpoints. So this D is the midpoint of D is the midpoint of BC, okay? E is the midpoint of AC, and F is the midpoint of AB, okay? They are the midpoints. So now what we has to prove? We has to prove triangle FBD. So this triangle FBD, okay, it is similar to triangle DEF. It is similar to triangle this DEF, okay? So these two triangles are similar. That thing we has to prove. And next what we has to prove, triangle DEF means again this center triangle, small triangle DEF, okay, it is similar to bigger triangle, this ABC bigger triangle. So this both thing we has to prove. Okay, so for similarities we know three criteria. So three sides should be equal, either three sides should be in same ratio, or two angles should be equal, or it should be two side and one angle. Okay, so here just before proving it, it should be there in your mind that how you are going to prove it. So like here, these two things, how we can find out these two triangles, what are the things we can find out which is equal. Fine. So here you see, so here F is midpoint and D is midpoint. Okay, midpoint means it's dividing two sides of triangle in same ratio, means this is a 1:1, and here also it is 1:1. So what we have learned, so if any line which divides two sides of a triangle in same ratio, so then that line will be parallel to the third side. So then your this FD will be, this line is parallel to the third side. So let me delete whatever this extra mark I have given, so it will be confused to you. Yeah. So what I said, so your DF is parallel to AC. This big side is a parallel to AC. Fine. So next, and in similarly we can say this two is a parallel. Similarly what we can say, so when this is, and this side, similarly we can say this side, okay, this side will be here, this side, this is the midpoint again, and here also it is a midpoint. So this side is parallel to this side. It means this one and this one is a parallel. Okay, so here what we have observed, so yeah, so FE, it is parallel to BC. Here FE, it is parallel to BC. Parallel to BC means it will be parallel to BD also. Okay. And similarly, we can say that ED also parallel to this AB, bigger side. So maybe it will be parallel to FB also. Okay. So now this small structure, this quadrilateral, it will be a parallelogram because opposite sides are parallel. Fine. And when opposite sides are parallel, so we can say that this angle will be equal to this angle. How that will be equal? So that is the properties of parallel lines, where this Z formation is there. So this is alternate interior angle. Okay. Similarly, here this FE, it is parallel to BD. Here also Z formation is there. Z formation is there. Okay. So this angle is equal to this angle. So you here this angle will be equal to this angle. Okay. So then this also is equal angle, means like in this true triangle, what we see, two angles are equal. So when two angles are equal, this true triangle will be similar. In that way, we can prove. So like here, you see, so whatever already we have done, EF is parallel to BC. Similarly, DF is parallel to AC. Aradhya beta, so recorded. So ma'am, at the end of the class, so ma'am will let you know. So recording you will get or not. Huh? So here EF is parallel to BC, DF is parallel to AC, DE is parallel to AB. That already we have shown to you. Okay, that is by basic proportionality theorem. Fine. So here BDEF, that's why it is the opposite side are parallel. That's why this is a parallelogram. Okay, and in parallelogram, angles will be equal because it is a parallel side. Okay, so these angles will be equal. So your two triangles is similar by angle criteria. Okay, so first thing we have proved. Now we have to see small triangle and bigger triangle. So in a small triangle, so we know that side will be half of that. Okay, so that ratio will be, so there's a midpoint theorem. Okay, so midpoint theorem, what is it? That is the extension of your Thales theorem. Fine. So where midpoint theorem says that side of, if one, that the midpoint of one side on a triangle, midpoint of other side of a triangle, when you will connect it, okay. So this is ratio 1:1, 1:1. Fine. So then this line is parallel to this side. That is like from Thales theorem only. And one extra thing is there. So this line will be half of this. Means if it is a ABC and this is a DE, so your DE will be half of BC. Half of BC. So that concept we are going to use here. So here your D is half AB. Okay. So whatever I have done this, let me remove, then you can clearly see. Fine. So here it says that your D is half of AB. Here this D, it is half of AB by midpoint theorem. Similarly, EF will be half of BC and this FD will be half of AC. Okay, so that we have written here. So now their ratio will take DE is to AB. Okay, so D is to AB and EF is to BC and FD equal to CA. Everything is 1/2. Okay, here we have taken DE is to AB will be half, EF is to BC is half, DF is to AC is half. Okay, so when side of two triangles ratio is the same, okay, so both triangle will be similar by SSS criteria. Okay, so in that way we have proved, so these two triangles is similar. Okay, like how you will get the marks. So first one marks you will get by this whatever the information they had given. Okay, so this step you will get 1 marks. So another one step you will get 1 mark. Okay, so this criterion here we have proved, so we got 1 mark. Okay, so like if it is a 3-mark question, this 3 marks will be divided in that way.
Excuse me, sir.
Yeah.
Sir, how did you prove that BF is parallel to DE?
What beta?
Sir, BF is parallel to DE. Can you please explain again how did you prove that?
Definitely. You see, so this line, what is here, it is midpoint. This is the midpoint, correct? It dividing this side into 1:1 ratio. Here also is 1:1 ratio. So what Thales theorem say that when this any point which divided or any line which divide two sides of a triangle in same ratio, it will be parallel to the third side. Correct?
Okay, yes, yes, yes.
Okay. So now when it is a parallel to this side, it will be parallel to this also.
Yes, yes. Okay, sir. Got it. Thank you, sir.
Okay, welcome. Now we have another question. So please go through this question, try to solve it, take 1 minute time. So then I will solve. So those who are solving, so please continue. Those who have a problem, so please look here. So here in question, it is given triangle ABC. Okay. So in triangle ABC, if AD is perpendicular to BC, here it is a given AD is perpendicular to BC. And another so relation they has given AD square is equal to BD into DC. Okay. So then we has to prove, so triangle BAC means this angle. BAC is a 90 degree. That we has to prove. So what we will do, so here this triangle, this small two triangles is a right angle triangle, fine. So these two triangles is a right angle triangle. So here we can say, so this triangle ABD, this is a hypotenuse. So AB square is equal to perpendicular square plus base square. So perpendicular is AD and base is BD. Okay, so AB square is equal to AD plus BD square. Similarly, we can say that in this triangle, AC is hypotenuse. So AC square is equal to AD again perpendicular square plus DC base square. Okay, so these two relations we can establish, fine. So now we will add this LHS, both equations LHS and RHS we will add. So here it is a AB square and this is AC square. So both we have added. So RHS also we has to add, that is AD square plus BD square. Here also AD square plus DC square. So 2 times AD. So it become 2AD square plus BD square plus DC square. Okay. So here AD, that is 2 times AD, fine. And this is BD square plus DC square. And in question it is given AD square is equal to BC into DC. So that value we have put here. AD square is equal to BD into CD. So 2 is there, so it become 2BD CD. Okay. Plus whatever is there, so BD square plus DC square or CD square, that we have written, fine. So now this become formula of in the form of A plus B whole square. This is A square B square, this is a 2AB. So this become A plus B whole square means BD plus CD whole square, fine. So BD plus CD, this is the BD and this is the CD. So this total is BD plus CD become BC. So this become BC square. So now AB square plus AC square become BC square, where BC will be hypotenuse and opposite angle of the hypotenuse is always a right angle, 90 degree. Fine. So that's why angle BAC is a 90 degree. Okay. So in that way, we can prove. If anyone has any problem, please let me know. Okay. So now solve this question. Again, try. This is D. So, okay. So here, so like in the given figure ABC and DBC. So two triangles are there in diagram ABC and DBC, and both has same base BC. Both triangle having same base BC. Fine. So it says that if AD intersect, there's a diagonal AD intersect another diagonal BC at O. They are intersecting at O. Okay. Then we have to prove area of triangle BAC, means area of this upper triangle, to the area of this lower triangle DBC. Okay. It will be equal to ratio of AO and OD. That we are going to prove. So what we will do? So we'll draw a perpendicular. So we have to do the construction. We will draw a perpendicular here. Okay. So I have taken this point is P. Another perpendicular from D we has to draw. Okay. This is the another perpendicular. Fine. So that I am taking as a Q. So this is a P, this is a Q, this is perpendicular. So this angle will be 90 degree. Okay. This angle is 90 degree. Clear? So that construction we have done. So those things also he has to write. If you do any construction that he has to mention. So like draw AP perpendicular to BC and DQ perpendicular to again BC. Okay. So now we will take the ratio of their area, means area of triangle ABC, area of triangle ABC divided by area of triangle DBC. So we know area is half into base is your BC and height we have taken AP. Okay. And here, better let me change the color. Here it will be half, base again will be BC and height is your DQ. Fine. So this BC half will cancel. So this is equal to AP by DQ. Okay. So that relation we got. Fine. So now what we will do? So we will take this two triangles. So in triangle APO, this small triangle, both small triangle. So in triangle APO, APO and triangle DQO. Okay, both small triangle. So here two angles are right angle 90 degree, 90 degree. So what are the angles is 90 degree? So that is angle APO, APO. It is equal to angle DQO is equal to 90 degree. So why? Because we have done the same construction. We have drawn perpendicular. So we can write by construction. We have to write the reason. Okay. In the same fashion, we have done the construction. Fine. So that is the one thing. Second thing is two angles are vertically opposite angles. Okay. So here, like if you'll see, yeah. So here this angle. So this is little bigger pointers. Yeah. So this angle, yeah, this angle, this angle, this angle, and this angle, this angle. These are vertically opposite angle. Means if your triangle is something like one triangle is like this, and another triangle is like this. So this angle and this angle will be vertically opposite angle. Fine. So that two angles I am taking. So those are vertically opposite angles. So what are those angles? So angle AOP, that is equal to angle DOQ, angle DOQ. It is vertically, okay, opposite angle. So we know in two triangles, when two angles are equal, so both triangle will be similar. Okay, hence triangle APO, it is similar to triangle DQO. Reason will be by angle criterion. You must write the reasons. Wherever you are writing the statement, you has to write the reasons. So from where you got this point. Okay. So when these two triangles are similar, so their ratio of side also will be equal. So it is AP is to DQ equal to AO is to DO. So the ratio is equal. Fine. And when their ratio is equal, so triangle area related to those triangles, that also will be equal. So your this thing we can write. So area of triangle BAC is to area of triangle DAC equal to AO is to DO. Fine. So clear? Anyone has any doubt in this? Okay. So now this is the question. This is a case-based question, similar question you will get in your examinations. They will give you the diagram based on diagram. So he has to understand and then he has to solve the question. Take few minutes, try to solve it. Musti says 5 by 7. Okay. Question says, so triangle is a very popular shapes used in interior designing. Okay, so this rack is in the form of triangle. The picture gives above shown a cabinet designed by the famous interior designer. He is the largest triangle, means outer triangle is represented by ABC. So that bigger triangle, which is outer one, so that is this outer one. Okay, so that is ABC. Fine. Yeah. So ABC, and the smallest one with the self is represented by DEF. Okay, so here we have, so one triangle with self. Okay, with self, that is your DEF. Fine. So here PQ is parallel to EF. Here PQ is parallel to EF. Fine. And says that D is parallel to AB. So your this side is parallel to this bigger side. Okay, and this side is parallel to this side. So that much information they had given. So now what we have to prove? We have to prove this DPQ and triangle DEF. DPQ, this small triangle, and this whole triangle DEF. So they are similar. Okay, so when this two PQ, it is parallel to EF. So okay, so PQ, so these two are parallel. So your these two angles will be equal. So corresponding angle. So these two angles are corresponding angle. Fine. These two angles are equal. Similarly, here. Yeah, Pratik says, can we do through the A similarities? Yes, we can do it by A similarities. PQ by EF also be 5, 7. So fine. So yes. So here also these two angles are equal. Fine. So when two angles are equal, so this is small triangles and this big triangles, two angles are equal. So these two triangles are similar. Okay. So this is done. Next, if DP is 50 centimeter, it says that DP is a 50 centimeter. Okay, and P is a 70 centimeter. This P is 70 centimeter. So find the value of PQ by EF. So it says that PQ, this one, and EF, this is bigger one. So we have to, it is asking ratio of a small triangle to the large triangle. So here, if we want same thing here, ratio of this small triangle, that is a 50, and ratio of this side of large triangle, that is a 50 plus 70. Yes, Shamruddhi. Any doubt you have, beta? कुछ डाउट है?
No, sir.
Okay, okay, fine. So you raise hand. So लगा हमको कुछ डाउट है. Fine. So इसमें क्या करना है कि दोनों ट्रायंगल का रेशियो निकालना. We has to take the ratio of this small side and larger triangle side. तो small में क्या है? This is a 50 and larger, that is 50 plus 70, that is a 120. So ratio will be 5, 0, 0 cancel. So that will be 5 is to 12, 5 by 12. Fine. So PQ by EF is equal to 5 by 12. Fine. So next, if AM and DN are the medians of triangle ABC, so they are medians. Medians means that will be the midpoint. AM
Sir,
and
explain
yeah.
me. Uh, can you explain me this?
Which one? Which one? Which one? Beta?
About triangle you were telling. I joined late.
Okay, means like what are the things you have learned? Means like means like so lot of things we have explained, beta. So what you have missed?
Sir, actually, I joined now. So, what did you explain?
So
Sir,
I
can
think
you?
now it's like already is 54 minutes past beta. So means like similarities. We are discussing this topic 2 days. We are going to discuss. We are discussing similarities. So we have learned the criteria of similarities, how two triangles are similar, means like similar. 3 criterias we have discussed. And then if it is a similar, what properties it means like their ratio of side will be equal, their angles are equal. So those are the criteria, means like those are the properties of similar triangle. And based on that, we have solved the problem. So now that problem is going on. So I think if your video will be available, so you can go through the video. Okay. So
Okay, sir.
like everything immediately we cannot cover.
Okay, okay.
Okay. Okay. So I think you will go to through the video, you definitely will understand. It's not very difficult topic, easy topic only. So please go through the video. So your
Yes,
question
sir.
says that AM and DN are the medians of triangle ABC. So AM, So from AM, medians means opposite side, it will meet to the at the center point, means this portion and this portion will be equal, means BM and MC will be equal. And next, what is the medians? D and AM and DN are the medians of triangle DEF. Okay, so here DEF, let me erase this. Yeah. So here, so DN is the another median. DN is the another median here. Okay. So this and this also is a equal. So now what we have to in the triangle DEF respectively, then prove that ABM and DEN, they are similar. ABM is this half triangle and this half triangle DEN. This half triangle are similar. So here in question, what it is given, AB is parallel to DE. So these two lines are parallel. Like here you can see these two lines are parallel. So when they are parallel, so these two corresponding angles will be equal. So this angle will be equal to this. Okay. This angle will be equal to this. Fine. And so these two triangles so are similar. So their base angles will be equal because they are parallel. So this side also it will be equal. So these two big triangles are similar. Okay. So when these two big triangles are similar and their side ratio, when they are similar, their side ratio also will be equal. Means this side ratio and this whole side ratio, if suppose this is a X. This also in the, means like if it is a ratio of X is to Y. So here also the ratio will be X is to Y. Ratio will be X is to Y. And when this, we have drawn a median, so it become Y by 2. So here also it is a median, so it will be Y by 2. Means still their base ratio will be equal. Side ratio and base ratio will be equal. And angle between them are already equal. So this two triangle will be similar by side angle side criteria. Okay. So this two triangle will be similar by side angle side criteria. So anyone has any doubt? Okay. So now these questions for practice.
Excuse me, sir.
Yeah.
The answer which they had given was 5 by 12. Was it wrong?
No, but a 5 by 12 we have got no here.
Oh,
Other
okay,
things,
sorry.
no problem, no problem. Here we has to prove. So this is the
Yes, sir.
okay. So now just go through that another 5-10 minutes. So we will continue. What are the problems we are able to solve? So we will do it. After that, 1 or 2 problems if you left, you can practice yourself. So try to this first question. In first question here it says triangle ABC. This is a triangle ABC. Okay. Here PQ is parallel to BC. There's a line PQ which is parallel to BC. ठीक है, दोनों पैरेलल है. Here it says that PB is 6 centimeter. ये PB जो है 6 centimeter है. This is a 6 centimeter. Okay. AP is 4 centimeter. Here AP is 4 centimeter. This side is a 4 centimeter. AQ is 8 centimeter. This is 8 centimeter. Okay. Then we have to find CA, this whole length. Okay. So here what we have, this AQ we have and we required AC. Means we have AQ, we required AC. So from this side also in the same ratio we have to take AP by AB whole side. So here also we have to take AP by AB. Now just put the value. AP is your 4. AB is 4 plus 6. Okay. So that will be 10. And one thing you has to keep in your mind, this is not exact value. This is a ratio. Okay. So if you want, here we are writing in the form of ratio. So that's why we are not writing X. Otherwise, actually, it has to, whenever two things are in ratio, like length and breadth is in 2:3 ratio. What will be a length? It will be 2x and 3x. We have to multiply with factor. But when we are taking the ratio 2x by 3x, actually x will cancel. We can write 2 by 3. So here I am writing in the form of ratio. That's why I'm not putting the x. That you has to keep in your mind. Fine. So here AP by AB, that is a 4:10 is equal to 8 by AC. So your AC is equal to 8 into 10 by 4. 4 to the 8, 2 10s are 20. So your answer will be 20. Yeah, Avni, correct. So that will be 20. Fine. So Pratik has answered for question number 2. That is 1.9 centimeter. I think maybe correct only. So just see this question number 2. So just I will erase it and then we'll start solving. Yeah. So question says that a girl of the height 100 centimeter walking away from the base of a lamp post, means there is a girl of 100 centimeter, means 1 meter. Okay. She is walking away from the lamp post. Height of the lamp post is 1.9 meter. Oh, sorry. So where is the base of lamp post at the speed? That is speed is, sorry, 1.9 meter per second. Lamp post is 5 meter. This is a 5 meter. Okay. Height of lamp post is 5 meter. 1.9 meter per second. She is moving after 4 seconds. So that will be 7 point, after 4 seconds, she will travel 7.6 meter. Okay, so that much distance she has already traveled after 4 seconds. So it is asking what will be her shadow, length of shadow. So shadow will be formed something like this. Okay, and this will be her length of shadow. Right, that we has to find out. So just will give the name of this triangle A, B, this is a C, okay, and then this is D, and this is E. Okay, so now this triangle ABC, and this is small triangle, your EDC. So these two triangles are similar. Why they are similar? Because here 90 degree, here also 90 degree. Okay, and this angle is common between them. So two angles are equal. So this small triangle EDC and this big triangle, full triangle ABC, both are similar. So their ratio of sides will be equal. Okay. So ratio of sides will be what? I'm assuming this is as X. So it will be, I'm taking this side, bigger side, 7.6 plus X, that is BC, by this DC, this is small side, that is X. Means big triangle base by small triangle base. It will be equal to big triangle height perpendicular by small triangle height, that is a 1. Okay. So just calculate for X. So X will be here 7.6x, 7.6 plus x is equal to 5x. Okay, x will go that side, it will be 4x is equal to 7.6. So x is equal to 1.9. So length of the shadow will be 1.9 meter. So hope everybody understood this. Okay, so remaining questions, so you can continue. Just this is the objective. This is the objective. So which of the following statement is false? Isosceles triangles are similar. All isosceles triangles cannot be similar. Like isosceles triangle can be like this. Isosceles triangle can be like this. It cannot be similar because angles are not equal. Okay, so this is the false. So another two questions. So please solve yourself in your home. Fine. So okay, hope you people enjoy the class. Okay, so then if any doubts are there, so small things, so you can ask.
Yes, students. So in the next session, there will be triangle part 2, which is also important. So please stay connected. The next session will be on Friday. Okay. So please join the session on time and learn and practice and revise your chapter triangles part 2. Thank you, sir. Thank you, students, for
Thank you.
joining.
Thank you. Thank you, everyone.
So we can show the answers to the previous questions. Just give me a minute, I'll share.
Ma'am, so one student asked regarding that video will be available for them.
Yes, all videos are available on YouTube channel, which is, I'll just share the link also. It is MTG Books YouTube channel. All the videos are there. So I'll share the link also in the chat box of the YouTube channel where you can find the videos. Okay. The link of the video of today's session so that you can watch it later on YouTube. All the videos will be available on MTG Books YouTube channel. You can go and revise it. Okay, sir. Thank you. Thank you, students. So we can end up the session now. Before that, sir, could you please go to the last slide to reveal the answers of the previous session questions?
My last slide, ma'am.
Yes, sir. Yes, sir. You can note down the answers of the previous session. So this session questions answer will be revealed in the next session, upcoming session. Okay. So thank you so much and goodbye for now. We can end up the session now. Thank you and Merry Christmas to all of you. Enjoy your holiday. Thank you. Bye bye.